Any questions about that? Okay. And then, all MPI implementations likewise make an MPI-CC variable available in the environment at build time too. So if your make file relies on MPI-CC, that'll just be set automatically at the build. If anyone wants to go into details on how these things are done, we could look at some packages that do them. Are people interested in that? Yes. You, okay. Sure. All right. So let's just go through the script a little bit. So we're going to go to advanced topics and packaging, and let's see. I'm going to I'll start going through this. We've got about 30 more minutes left. We'll go through this part of that. So for this part of the tutorial, there are some things that we need to do to set up first. So I think I removed GCC 7.2 for the environment section. We need to add this tutorial repo. So there's a dummy repo for some of the packages that we're going to deal with. If I do that, I'm going to just say Spack repo add scope equals site var Spack repos tutorial. And let's see. Oops, sorry. I'm going to go to the home directory, and I'm going to cd into the Spack installation. And so this is where the var directory is. Now I'm going to Spack repo add var Spack repos tutorial. Okay. And so this is just a special repo that we've provided for the tutorial that has some packages that need to be edited in it. And then I'm going to go and just make sure that my compilers are installed. So this is the GCC that I want to use. Where are we going? Oops. I guess I should have done that before. Oh, because these are in the wrong order. Sorry. So I'm going to remove that repo that I just added. Var Spack repos tutorial. Spack repo RM tutorial. That's weird. Have you seen that happen, Greg? Am I in an environment? Yeah, okay, sorry. So despacktivate. Don't be in an environment. Okay, we're not in an environment. Spack repo RM tutorial. Wasn't seeing that. Really?
You ever add it?
Oh, I never did because I added it in the environment. So list. No, it's there. So hold on. See if I can remove this.
The repo RM command is an environment aware.
We're not in an environment though. Am I forgetting something stupid? No, remove is there. I'm going to use Spack config blame to see where that's coming from. Okay. Oh, because it's the wrong scope. That's because I did scope equals site. Okay. So what I would have had to type is Spack repo rm scope equals site tutorial. We should fix that. That's a little overly confusing. So there are some places where Spack does not yet know exactly what you mean, and they could be improved. Okay. So now if I do Spack repo list, fine. Now I'm back to here. I'm going to make sure that this compiler is installed. So I'm going to install GCC 7.2 okay, it's already installed. Awesome. So I didn't even need to do all that. And then I'm going to make sure that compiler is added. And so what I'm doing here is I'm saying add this compiler with scope site. So that means basically put the configuration in my Spack instance. And then I'm going to use the install location of GCC 7.2.0 with that spec. Okay. So now I have the compilers I want. I don't even think I actually need to do this to edit the files for this part of the tutorial, but okay. Here's GCC 7.2.0, and we're good. All right. So now I can go back here, and I'm going to add the repository that I want for this part of the tutorial. And I'm not in the Spack directory. I'm just going to use an absolute path. Add that one. Okay. So I've added my repo for this part of the tutorial. Okay. So the first thing that we're going to look at is packages that can set variables in dependent packages at build time. And so this is basically if your package like Qt requires like the Qt dir variable be set to use the libraries, right? If people have used that. if you need to set some environment variables, or like the MPI compilers, we want to have the MPI implementations in Spack provide this MPI CC variable to all of their dependents. You can use this method called setup dependent environment. And so what you would do to do that is you would basically just say Spack edit, and we're going to edit the mpitch package. So here's the mpitch package. It is rather complicated because there's a lot of logic that we provide here, but there's a lot of options. But if you scroll down, you can see all the dependencies in here, and then you can see this setup dependent environment method. And so for the tutorial, I mean, what we're tasked with doing here is just making sure that we set all of these environment variables for dependence. So the setup dependent environment method, I mean, if you don't define this on your package, it's just ignored. Nothing will happen. But basically, you define this method if you want to provide settings for your dependents. And what your path is, so self is just your package. The Spac environment is the build environment for this dependent. So that's the environment within Spac at build time. And the run environment is if you want to add something to the runtime environment for that package. So if I have, some application that depends on MPI, and I wanted to make sure that whenever that application runs, whenever someone loads the module for that application, that it sets some environment variable having to do with MPI, I could do that here, right? So you can actually have dependencies setting environment variables for their dependents in Spac, and that'll show up in your module files and in environments when you activate them. Does that make sense? Okay. It's convenient because you can basically specify the setting in the right place. It's a setting that comes from the MPI implementation, and so you can set it there, and it's done for all dependents. So what we're going to do here is make sure that these MPI-CC parameters are set. And so what we want to do is ensure that this MPI-CC setting is available at build time. And so I want this variable to be set to that value. And so what I do is I just write Spac env.set MPI-CC to that. Right? And so what that's saying is I'm going to set MPI-CC to my prefix/bin. That's the bin directory within my prefix, the MPI installation, /MPI-CC. That's it. And I would do that basically for all the others in here. So I'm going to just do the same transformation here, Spac env.set MPI-CXX, join past that stuff. And I'm going to just copy and paste it from here. And this is super annoying. Yeah. There are ways to make Emacs behave nicely for this. My Emacs, for instance, behaves nicely, just not the one in this VM. All right. So what have I done? I've got MPI-CC, MPI-CXX, F77, and F90 all set to their respective MPI compilers. So now those environment variables will be available to packages that depend on MPI in the Spac build environment. Right?
One path is just OS path join.
You can use OS path join if you want. Yes.
I just wondered if it was doing something else.
No, it's not fancy. You can even, honestly, you can do this. You don't need the join path here because the strings are valid Python. For this one you do because it has pluses in it. But for these down here, you actually don't need the special stuff. Okay. And then for env set, mpitch cc to Spac cc, this is actually kind of interesting if people are interested in what Spac really does at build time. We mentioned that we like to have compiler wrappers for everything, right? And that the compiler wrappers are injecting RPaths. Well, if you use the MPI wrapper, right, that is not our compiler wrapper, right? That is MPI's compiler wrapper. It turns out that all the major MPIs now have these variables like mpitch cc or ompI cc that you can set in the build environment. And their MPI compilers actually respect that, and they say, oh, that's the compiler you want to use. So what we do is we inject our wrapper into the MPI wrapper using this environment variable so that it's using a compiler underneath that injects all the RPaths that we want. So these settings here actually ensure that in the Spac build environment that we're automatically adding all the RPaths that we need for MPI. Any questions on that? If you want the details on that, look at that MPI documentation section that I mentioned earlier. Okay, so now that this is done, we could go and install netlib scalapack with mpitch because it expects these variables, but I'm going to go ahead and skip that and look at some more configurations here. So the other thing you can do is, so we looked at set of dependent environment, which lets something like MPI set variables for its dependent packages. There's also setup environment, which is it's sort of the mirror image function, right? Where you get Spac env and run env, and you're setting variables either for this package's build environment or for this package's run environment. For this one, like we mentioned, that Spac forks off a process for every build environment that it makes. So to some extent, setting variables for the build environment here is a little redundant. You could do this part in the install method if you wanted to. This is handy if you're using AutoTools package or CMake package and you're not writing your own install method, where if you want to inject something into the build environment, you can do it through this method without having to override those functions, right? Otherwise, you could just go and set something in os.environment like you normally would in Python, or actually in all the Spac packages, we just put env in there. You can say env sub make flags equals whatever, and do it very naturally. But the real value of this is that you can set something in the run environment. And this is cool because this run environment variable actually goes into your modules. So if you want qtdir, for example, to be available to all the people who module load qt, this is where you would set it. So in the setup environment method, you would say run end dot set qtdir to your prefix, and then anyone who loads the module for this thing once it's generated will get that set in their run environment. Does that make sense? Okay. All right. And you can also, in the setup dependent environment, we also set qtdir because the things that build with qt need to have that set. One thing to note here is that for setup environment, there's one difference in the parameters here. For the dependent environment, we actually give you the dependent spec, right? So if you think about this, if you really want to understand how the Spac build mechanics work, it's building the DAG bottom up, and so it builds this package, right? And then it finishes that. It builds all the other dependencies of the eventual dependent, right? And then right before it builds the dependent, it calls this method and executes whatever is in Spac env, right? So this is a method in a dependency package that gets called right before the build of the okay. And let's skip ahead. I think this stuff is all fairly self-explanatory. Let's skip ahead to the library information. We kind of already saw this stuff in the slides. And this is all from the slides. Yeah. So now we're in this part where we were going to provide libraries to dependents, and we looked at this earlier. Wyatt had asked, if I'm going to provide libraries that are available when you say spec sub lophack.lib in a dependent package for a lophack dependency. So we're going back to this diagram now. Go back here. So if I am, say, rpack, and if I am the netlib lophack package, and I want to provide libraries for the lophack interface to rpack ng, I can implement methods to provide that. And so, kind of already talked about this, but the first property you can implement is libs. And so if you override this, Spac has a good default implementation that just looks in the libraries directory and returns all the libraries that are there. But if you want to override it, then you can override libs just like we showed with lophack libs earlier. And this is the one that provides the superset like you were asking, right? So this is the one that will provide all the libraries for that package. If you want to provide the libraries just for lophack, then like we showed earlier, you just define lophack libs instead. And so it's basically just a naming convention that we go and introspect and we use to provide to this spec interface, right? If you provide a property called lophack libs, we'll use that function to provide the libraries when someone says spec sub lophack.libs. And if you provide something called bloss libs, we'll use that function to provide the libraries when someone says spec sub bloss.libs. And so the same package can define both lophack libs, bloss libs, and as many libs methods as you have virtual dependencies. And that's how you provide that stuff to your dependent. And if you want to see examples of how this stuff works, look at any of the bloss providers or lophack providers in Spac already. And you can find those pretty easily. you can actually just go on the command line and you can say Spac providers LAPACK. And if I do Spac providers LAPACK, it'll actually show me all the things in Spac that provide LAPACK. Similarly, if I do Spac providers MPI, it'll show me all the MPI providers and when they provide different MPI versions. I could do Spac providers BLOS and see all the BLOS providers. And if you want to see examples of this stuff, then you could just do Spac edit one of these. So you can Spac edit netlib LAPACK. And then you'll find the LAPACK libs method there. And you can actually look at what it does. And so I guess, you know, one of the most useful things you can do if you just want to learn how to write packages in Spac is use Spac find aggressively to find packages like the one that you're trying to build. So if you're building something that depends on MPI, find all the packages that depend on MPI, or list all the packages that have, or grep around for packages that depend on MPI. If you want to know that statically, there's some other interesting commands you could use. I'm kind of going off script at this point because I think this is interesting to people. If you want to know what depends on MPI in the Spac built-in repo, you can just use the Spac dependence command. And so this will give you all the things that could possibly depend on MPI in the whole Spac repo. And it's going to go and compute reverse dependencies for all the packages that it has, all 3,000 of them. And then it'll show you what actually may depend on MPI. And so you can see there's a lot of packages in Spac that can depend on MPI.
Is that for direct dependencies?
It is, unless you specify -- transitive, and then you'll get all the dependencies. I'm not going to type that. But so if I go and grab any of these packages, right, like libmesh here, libmesh, and I Spac edit that, then I can go and look at how the package is written and see, what other people did. And so I think this is pretty handy. So if you know of a package that's kind of like yours, you can find it in Spac. Or if you know the thing that you're trying to link against that you don't quite understand how other people are using, you can use that Spac dependence command to find all the stuff that other people have done that dealt with that package pretty easily. Okay. The other thing that you can do that's kind of interesting is from this setup dependent package method. So you can define a setup dependent package method on your Spac package. And here you're actually passed something called a module and the dependence back there. And so this is different from the methods that we saw earlier because those set up the run in the build environment. This actually sets up the package, the actual module of the package. And so here we're kind of leveraging the fact that every Spac package has its own package.py file. And so the module scope in Python is that file, right? So it's you can poke magic global variables into the scope of your dependent packages. And so what this is doing is, like, if you want to have something like AC local or automake, these executables poked into the scope of your dependent so that they can be called like functions, you can actually do that by just defining setup dependent package, and then you can go and tweak what's on the module of your dependent. This is how stuff like the Python package provides that Python command. You can execute like a function for all the things that depend on Python. It basically just sticks it into the global scope for all of its dependent packages. Does that make sense? All right. And then dependent packages can do this in their install method. They can just call AC local -- force like it was a function. And it's kind of cool because you can put something like this in the automake package and allow people to use it as though they were on the command line within it. Okay, I'm going to skip the last section because I think it's just too much detail. And I think that's pretty much it. So do people have questions? Yeah.
Yeah, so we have a weird situation where we build software where two packages depend on each other.
Okay.
And so we have to build one, install it, then build the other one, and then you can rebuild the first one that depends on the second for installing it.
Okay.
And this is a completely manual process to get it right. So is there a mechanism by which you can have circular dependencies that here the Spac will break out of and do the right thing?
I guess I question what the right thing is to do when you have circular dependencies.
You've already thrown that out the window.
Well, yeah, so I guess the answer is that we haven't really spent a lot of time trying to support circular dependencies in Spack, so we pretty much don't. It's a DAG right now, for the dependency graph. And we don't really have a good way to handle that. One example of where people have handled that is, in XSDK, which, Jonathan mentioned earlier today. There was a circular dependency, between, so Trilinos depended on Petsy and Petsy depended on Trilinos, in a certain way. And so what they did to deal with that was they broke off a separate Trilinos XSDK package that depended on Petsy, and then Petsy depended on Trilinos. So they took the parts of Trilinos out, that depended on, the thing causing the cycle, and they made it into a DAG. That's the only instance I know of someone dealing with that directly. Although Jim tells me that if we factor Trilinos into multiple packages, we will encounter this problem as well. So it may be becoming relevant.
Not if we do what mentioned at the end, right?
Okay, so we may not even have to do that. I guess I would rather not have to deal with that, because I think it's a weird scenario. There are nice things that, so one of the things I would like to eventually do with Spack is to have solutions read-only, and that sort of goes against having circular dependencies too, because like if you have a circular dependency, you have to build one, you have to build the second one, you have to build the first one again, typically. And it's nice to have sort of immutable installs, because it gives you some nice functional properties to your packages, and it helps with reproducibility. And so, I don't know, the only thing that we have in Spack preventing that right now is the activation feature that I mentioned for Python, and I think what we'll end up doing is taking that out and just having environments in the end. So, I don't know, if we handled circular dependencies, we'd have to kind of think about how those two conflicting goals relate. So I guess if there's any way you can not have circular dependencies, don't. It's not the most satisfying answer.
It's not us.
Yeah. Which package is it?
Probably the ones that you just talked about.
Oh, really? Okay, that's interesting. Oh, it's Petsy and Trilinos?
Yeah, that kind of stuff.
Okay, so we may already have that handled within Spack.
Yeah, but we're not, our current build system is in Spack, right? So we're looking at options to move off of that and not having to deal with stuff like that.
Okay.
That was a general question.
Yes. Okay, yeah. So we have handled the Petsy Trilinos problem within Spack already. And so that may be partially addressed. Any other questions? Yes.
Could you offer some advice for a package that might be using two different compiler wrappers? For example, the HDF5 and NDICC compiler wrappers?
Oh, that's interesting. We haven't actually, so do we have other packages that use the HDF? I didn't know that HDF5 had compiler wrappers.
H5CC.
Yeah, does it support a way to inject another compiler in? Because essentially, like, if it has this capability that the MPIs do, where you can set an environment variable and have the HDF5 compiler wrappers use a different compiler, then you can easily
Whatever it was built with.
Sorry?
I believe it uses whatever it was built with.
Yeah. So in that case, we would probably do something like what we did with MPI, but we may just patch it instead of having a nice environment variable like we did MPI right now. So we would just patch the compiler wrappers. We already patched the MPI compiler wrappers when they're installed. You may have noticed that. So I would look at that code. And then join us on the Slack channel, because people are there and can help with stuff like this, especially like the core developers like Greg and Peter. Anybody else?
I think you comment briefly on the patching operation. I've seen it in quite a few packages, and I'm just curious, like, when does it usually come up?
Oh, okay, sure. So actually,
You already patch H5CC.
oh, nice. Okay, so yeah, the answer to your question is we handled that already.
Compiler wrappers function on them.
Okay.
Which is what we do on the MPI compiler wrappers also, which takes the Spac compiler wrappers out from being an integral part of the process after they were created.
We can talk about the details for that offline, because it gets a little hard to explain. Okay, what was I gonna look? What was your question? Patches?
Yeah.
Okay. Look at this one. Okay. Does it have a, yeah, okay. So, I guess we should mention this. This is maybe not the best package to look at for patches. Is there a cleaner one, Greg, that has a known patch? Does Zlib have a patch?
No. HDF5 does, but the HDF5 package is actually kind of long.
Well, but the patch directive might be nice and clean. Yeah, okay. So this is a very simple example of a patch. So this just says patch, and it gives you a file name for the patch. And then it just says, use that patch when I'm at this version and running with this compiler. And so in this case, this just says, use this patch when I'm at version 1.10.1 and when I'm being built with Intel 18. And so the place where you would put that patch, actually dash E, HDF5. This is the packages directory, and so this is basically, this is where the package.py file lives. So all of the built-in package.py files live in var Spac repos built-in packages HDF5. So if you run Spac create, like Greg showed earlier, this is where your package will be created by default. And so you can see there, that's the package.py that would have been created. And also in that directory is the patch file, right? So if you just say patch and refer to a file name, it's going to come out of this directory. And it just lives with the package.py file. The other way that you can do a patch with your package, and I guess I should talk about that a little bit. If you do this, if you say that there's a patch on your package, it means that patch will be applied immediately after the source gets checked out, right? So we'll either fetch the tarball, expand it, and then apply patches, or we'll clone the repo and then apply patches to the repo. Does that make sense? So by the time you get into install, you're guaranteed that the source has been fetched, you're in the source directory because it's been expanded, and all the patches have been applied, if you put the patch directive in your package. And so there are other interesting things about patches that you can do in Spac. And so let's see. The QMC pack folks, they use patches at particular URLs. And so they're kind of splitting this. I guess they decided that the lines were too long. So they defined the patch URL to this URL, right? This is some website that they host. They have a checksum here, which is the SHA-256 of that patch. And then in here, they're just saying there's a patch, it's at this URL, it has this checksum, and apply it when I'm at this version. And so all this is doing is, it's basically the same thing as the other patch directive I showed, it's just that the patch doesn't live with the package. It's fetched at fetch time. And so we fetch it from this URL, we verify it with that SHA-256, and then we apply it before the thing builds. An interesting thing about patches is that we take this SHA-256, right? If the file lives in the repo, we just compute the SHA-256. And if the file is fetched, we just use this SHA-256. This actually goes on the spec. So if you build a package with a patch, it is separate from a configuration of the package without the patch. So we actually model that, and you can have versions of Spac packages installed with different patches, and that will be modeled on the spec of the package. So they will have different hashes. This hash will be included in the hash, in what is hashed for the installation of the package. Does that make sense? Because you're modifying the package, right? The patch is going to do something different. So effectively, you're building a different version, and it should have a different hash. The other kind of cool thing, this is something that we sort of introduced specifically to support this package. But you can have a dependency that has an associated patch in Spac. Okay? So it turns out that the QMC pack people, for whatever reason that I can't explain, they maintain some sort of 40,000 line patch on one of their dependencies. Which sort of, if you wonder why they do this, I don't know. It's not ours to ask why. But you know, they're a key code for ECP, and so we wanted to be able to support this. We wanted to get them into the Spac ecosystem, get them having a reproducible build, and you know, the fact that they do disgusting things in their package file is sort of beside the point. If we can get them in the community, then we can teach them that this is a bad idea. Okay, so we added this feature. And what this means is that, so this depends on Quantum Espresso at 6.3, without Alpha, without Scala Pack, without MPI, and with HDF5 enabled. With this patch, when Quantum Espresso is built with plus QE and minus MPI. And so I don't know all the details of these configurations here. But essentially what this says is that a special version of Quantum Espresso will be built with this patch just for QMC packs. Okay? And so it is isolated from the other packages. It means that it doesn't interfere with the other stuff in your Spac repo, right? If you tried to do this in RPM, right, if you went and modified the Quantum Espresso package with this patch, and it broke binary compatibility for something other than QMC tag, it would never work, right? Because QMC tag couldn't coexist. But because we support this feature, we're able to actually we're able to fetch this, this patch, we're able to put this SHA-256 on the spec of Quantum Espresso, and that makes it a special version of Quantum Espresso with its own hash, and we just build it separately. So the hashing works really well for use cases like this. And then this patch syntax here, this keyword argument, this is just the exact same patch syntax that you would use at the top level of the package. You just pass it as an argument to depends on in our case, and it works. So I don't know if that's good or bad, but you can think of this like it's a community improvement program, bringing people into the Spack community, trying to help them get off practices like this, but we're also supporting it in a way that it interoperates with other things. Other questions? Yep.
There's some codes that dynamically download patches.
Yes. So we really want your build not to download things. And some of the packages have had to have modifications so that they won't do that. If you're going to download something in Spack, we want it to be downloaded either as a patch, as one of these tarballs for a version, or there's another directive called resource that you can add to your package. If you need like multiple tarballs for your package, like look at the LLVM package if you want to see something like this. You can download things called resources where you fetch multiple tarballs, and they're expanded in different places within the build stage. And the reason that we want that is because Spack has to work on air-gapped networks, right? And so if the packages that people put into Spack are just fetching things all over the place, it's never going to work on the secure side when we try to rebuild the thing. And so we have to be able to mirror all of your packages and put all the artifacts that are needed to build it into a Spack mirror. And so that's why we want it modeled. It generally hasn't been that hard to fool builds into thinking that they've downloaded things. The only one that was particularly hard in that respect was TensorFlow, but there are so many things wrong with TensorFlow that I don't even want to get into it. And you know, the build is just hideous, both because of Bazel and because of the TensorFlow build itself. So beyond that, I have not had much of a problem patching builds so that it would download things. Other questions? Okay, well, so hope you liked the tutorial today. We will pick up tomorrow morning with some talks about ECP deployment, and we'll also have free time to sort of work on packages, and we'll be, I guess, Greg and I will be going around the room helping with people with problems or answering questions.